Hello everyone, this is your course instructor Harshita. Now in second module, we have got to study about Shannon's encoding algorithm. So let's consider an example how we apply Shannon's encoding algorithm for the given source. And we'll also see how the same algorithm is applied for the second order extension of the given basic source. So let's consider an example which says apply Shannon's encoding algorithm to the following messages: S1 equal to 0.5, S2 equal to 0.3, S3 equal to 0.2. First sub-question is find code efficiency and redundancy. Second sub-question is if the same technique is applied to the second order extension of this source, how much will the code efficiency be improved? So first analyze the problem. What is given in the problem is there are three symbols, namely S1, S2 and S3, and the probabilities of the three symbols are given as 0.5, 0.3 and 0.2. The first and the foremost thing that we are supposed to do in Shannon's encoding algorithm is to arrange the given probabilities in descending order. So descending means from largest value to the least value. So amongst these three values, that is 0.5, 0.3 and 0.2, the highest value is 0.5. So I am writing that first, and next highest value is 0.3 and next is 0.2. So I'll write 0.3 and 0.2. So what are these? These are nothing but the probabilities of the three symbols, right? So write pi, and in the next column write alpha I. Alpha I for the first value of probability will always be 0. So first I'll enter 0 here. Next, how will I find the second value? So if you please observe this arrow mark, 0 plus 0.5 I'll be doing, and then the total sum I'll be writing it here. And next, the third value, how will I find it? This 0.5 plus 0.3 I'll be writing below 0.5. Alright, so 0.5 plus 0.3 is 0.8. So the third value is 0.8. Now, next I'll have to find the length, that is Li. So for this, I need to remember a relationship between the length Li and the probability Pi. So there is this relationship to find the length. So what is that? Log of 1 by pi to base 2 less than or equal to Li less than 1 plus log of 1 by pi to base 2. Now I'll be substituting all the three values of probabilities, 0.5, 0.3 and 0.2. So first let me substitute the value of probability, that is 0.5. So it becomes log of 1 by 0.5 to base 2 less than or equal to L1 less than 1 plus log of 1 by 0.5 to base 2. So now after substituting and calculating with the help of the calculator, we can find that the value of L1 is 1. And similarly, I'll substitute the probability values 0.3 and 0.2 in this relationship, and I'll find that L2 and L3 is 2 and 3 respectively. Now, what is this Ci? This is the binary value of the alpha I. So now the binary value of 0 is 0. So I'll be writing 0.00. Next, the binary value of 0.5. So how will I calculate the binary value? So I'll take up this alpha equal to 0.5, that is in decimal, so I'll write 10 as the subscript. So now I need to convert it into a binary value. So I'll multiply it by 2. So 0.5 into 2, I'll get it as 1.0. Okay. So this 1 here is the carry, and the solution or the answer is 0. So 0 with carry 1 is the final answer. Okay, so this 1, that is nothing but the carry, is the binary value of this 0.5 in decimal. So I'll write 0.1 subscript 2 because it is in binary. So next, let's take up the third value of alpha. That is alpha 3 is 0.8 in decimal. So first thing, I'll multiply this 0.8 by 2. I'll be getting 1.6. So now this 1 here is the carry. Answer is zero point 0.6. So zero point 0.6 with carry 1. Next, I'll be multiplying this 0 0.6 again with 2. Okay, so 0 0.6 into 2 is nothing but 1.2. So this 1 again is the carry here. So I'll write 0.2 with carry 1. Next, again I'll multiply this 0.2 with 2. I'll be getting 0.4. So answer is 0.4 with carry 0. So the binary value of this is 0.110 in binary. Next, after calculating the binary value of these alpha, I'm calculating the code word. So how will I calculate this code word? So by looking at this column of CI and the value of the length, I'll be writing the code word. So how will I do that? The value of Li here is 1. So I'll be restricting the code word for 1 digit or 1 bit after the decimal point. So after the decimal point, I have 0 and 0, but the length is only 1. So after the decimal bit, after the decimal point, I'll be considering only 1 digit. So that is 0. So I write 0. Next, after the decimal digit, decimal point, I'll be considering up to 2 bits. So because the length is 2. So it becomes 1 and 0. I'll be adding another 0 because the length is 2. Next, here the length is 3. So what am I supposed to do? I should be considering 3 bits after the decimal point. So it will be 1, 1 and 0. So now after writing this table, we are supposed to calculate the average length. So formula for average length is summation of I equal to 1 to 3 product of probability and the length. So probability you can find it here in the first column and the length is found in the third column. So I'll be multiplying both the probability and the length respectively. So the summation I equal to 1 to 3 because there are 3 different symbols. So substitute the 3 values of probability and the length and calculate. You'll be getting average length as 1.7 bits per symbol. Next, we are supposed to calculate the entropy. That is, h of s is equal to summation of I equal to 1 to 3 pi log 1 by pi to base 2. After substituting the probabilities, you'll be getting this equation, and with the help of calculator, if you calculate, we'll be getting entropy as 1.4855 bits per symbol. Next, efficiency. So how will I calculate this efficiency? This efficiency is nothing but the ratio of the entropy and the average length. So entropy I've got it as 1.4855 and length I've got it as 1.7. Now this efficiency is always measured in terms of percentage. So I'll be multiplying by 100. Okay, so I'll get the efficiency as 87.38 percentage. Now I need to calculate the redundancy. The redundancy is nothing but 1 minus the efficiency into 100. So 1 minus efficiency is converted back from percentage to the normal unit. So we'll be getting 0.8738 and then multiply. So we'll be getting redundancy as 12.62, or else you can also do 100 minus 87.38 percentage, for which you'll be getting the same value, that is 12.62 percentage. Next, please go back to the question and read this second sub question. Now the finding of the code efficiency and redundancy for the basic source is done. Now read the second sub question again. If the same technique is applied to the second order extension of this source, how much will the code efficiency be improved? So how will I extract the second extension of this source? Since there are three symbols here, the second extension source will have 3 to the power of 2 symbols, that is total of 9 symbols. So how will I analyze that? See here, there are 3 symbols, right? The possible combinations of all the 3 symbols I'll take. So for example, first I'll take up S1. S1 combination with S1, S2 and S3. Next S2 combination with all the 3. So S2 with S1, S2 with S2, S2 with S3. Next S3 with all the 3. So S3 with S1, S3 with S2, S3 with S3. So the probabilities of S1, S2 and S3 are given as 0.5, 0.3 and 0.2. So substitute all the values and calculate the values of probabilities of all the 9 symbols. After that, follow the same procedure that we followed for the basic source. That is, the first step that I'll be doing is the arrangement of the probabilities in the descending order. So after arranging the 9 values of probabilities in descending order, I'll be getting this. Okay. Next, I will writing the value of alpha I in the second column. So the first value of alpha I will always be 0. And the second value is the sum of 0 plus the value of first probability. So 0 plus 0.5 is 0.25. I'll be writing below 0. Next, draw this arrow mark, and 0.25 plus 0.15 I'll be writing here, and 0.4 plus 0.15 I'll be writing here, 0.055 plus 0.1 I'll be writing here. So similarly, I'll draw the arrow marks in this direction and I'll fill up the entries in the second column. Next, in the similar way, I'll be calculating the value of length using the relationship between the length and the probability. So, as we did for the basic source, the same thing that we are going to do here, and I'll calculate the value of Li. Is that all right? Next, how will I find the code word? This is very simple. I've already explained how to do that. So just substitute the value of probability and then you'll find out the value of the length. Next, how will I find out the code word or the binary value of the alpha I? So first, alpha I is 0. The binary code word for that is 0.00. Next, the second value of alpha is 0.25. So how will I convert it to binary? So 0.25 into 2, I'll get 0.5, which carries 0. Next, this 0.5, I'm multiplying it by 2 again. So I'll be getting 1.0. So now this 1 is nothing but the carry and the answer is 0. So it is 0 with the carry 1. So the binary value, I'll be writing it in this direction, top to down. So I have 0 and 1. So I'll be writing 0.01 in the subscript is binary because it is the binary value. So I'll write 0.01 here in the second row. Next, this 0.4, 0.55, 0.65 and similarly all the values of alpha are converted to the binary value as we did for the first value here, and we also learned it how to convert it into binary while doing it for the basic source. Okay. Next, I will have to write the code word considering the length. So I'll consider this length and the code word. So since length is 2, I'll be considering 2 bits after the decimal point. So it is 0 and 0. Next, for the second symbol, I'll be considering up to 3 bits after the decimal point. So since there are only 2 bits here, I'll add one more 0. Okay, the value doesn't change. So it is 0, 1 and 0. Next here, length is 3. So I'll be considering 3 bits after the decimal point. So that is 0, 1 and 1. Next, here I'll be considering 4 bits after the decimal point. That is 1, 0, 0, 0. So like that, here these two are also the same. I'll be considering 4 digits after the decimal point. So it is 1. I have only 1 and 1 here. So but I need 4 bits after the decimal point. So I'll add 2 zeros. Okay. Next here, I'll be considering 5 bits after the decimal point. So that is 11010. 11100 11111 and 0. So next, after filling up the entries in this tabular column, next I like to find out the average length, entropy and the efficiency. So average length is given by L2 because this is a length of the second extended source. So L2 is given by summation of I equal to 1 to 9 because there are 9 symbols and a product of probability and the length. So I'll be substituting the values of probability and the length respectively of all the 9 symbols and calculating the value of average length with the help of the calculator. So you'll be getting the value of L2 as equal to 3.36 bits per symbol. Next is entropy. The entropy of the second extended source is denoted as h of s square, that is given by 2 into h of s. That is, the entropy of the second extended source is twice the value of the entropy of the basic source. So the basic source entropy we have already calculated here. Let's go back and check the value of entropy of the basic source that we have got it as 1.4855, isn't it? So substitute that value here, 1.4855 into 2. So we're getting entropy of the second extended source as 2.971 bits per symbol. So now efficiency is nothing but the ratio of entropy and the length. So efficiency, that is eta C2, is given by h of s square by L2, or you can also just write L, doesn't matter. So it is 2.971 by 3.36, that is 88.42%. Next, a redundancy is given by 1 minus eta C2, or you can also do 100 minus efficiency, or you can do 1 minus 0.8842 into 100. Both the ways you can do, for which you'll be getting the value 11.56%. Next, in the question, they've also asked by how much value is the efficiency improved by if we consider the second extension. Okay, so the efficiency in the first case we got it as 87.38, whereas in the second extended source we got the efficiency as 88.42%. So let's take the difference of the two efficiencies. So we got 1.04%. So by this amount of percentage, the efficiency is being improved. Therefore, what can we conclude from this is that the efficiency of the second extended source is greater than the efficiency of the basic source. Thank you all.